Welcome to your bedtime lesson for today. Today we are going to be looking at rain. Now, at its simplest, rain is described as drops of liquid water falling from the sky. Clouds form when water vapor, a gas, cools and condenses to form water droplets as a liquid. But these droplets are so tiny they stay in the sky. To become rain, the water droplets must grow by acquiring more water and getting larger. Once they become heavy enough, they can fall to earth. Some drops collide with others in order to get larger, whilst others will grow as water condenses out of the air into the droplet. Once these droplets become too heavy to stay in the cloud, we get rain. The size of the raindrops is highly variable, from as small as 0.5 millimeters in diameter to 6 millimeters. We are going to be looking at 4 parts of this video today. The first part is about a question about what causes flash floods. Find out what causes flash flooding and why it can be so dangerous. Now, what are they? Flash flooding happens when rain falls so fast that the underlying ground cannot cope or drain it away fast enough. Roads can become like rivers if there is a lot of water, it can flood buildings and carry cars away. So if the rain is falling too fast for the ground to drain or drains to cope, there is a risk of flash flooding. Now, what causes them? Most rivers flow fairly gently as they slope slowly towards the sea. Therefore, when a river floods, it does so quite slowly as it takes time for the rain to percolate through the ground and into the rivers and out to sea, allowing time for some warning. With flash flooding, there is often very little time between the rain falling and the flash flooding occurring. Flash flooding commonly happens where rivers are narrow and steep, so they flow more quickly. It can also occur from small rivers in built-up urban areas, where hard surfaces such as roads and concrete don't let the water drain away into the ground. This leads to surface overflow and can be often overwhelm local drainage systems, leading to flash flooding. And finally, here's a case study in Boscastle floods in 2004. The village of Boscastle in Cornwall experienced flash flooding on August 16, 2004, when an exceptional amount of rain fell over 8 hours. Heavy thundery showers developed over the moors to the southwest of Boscastle. A small steep river flows through Boscastle, and the thundery showers came one after another in a short space of time, over the same spot at the head of the river. There was simply too much water for this small river and the surrounding hillside to cope with, and the water gushed rapidly down the steep slopes into Boscastle. Our second part is about freezing rain. Freezing rain is a rare type of liquid precipitation that strikes a cold surface and freezes almost instantly. The conditions needed for freezing rain are quite specific, and we don't see this phenomenon very often here in the UK. It can produce striking effects as the raindrop spreads out momentarily across the surface before it freezes, encasing the surface in a layer of clear ice. However, it is not just these eye-catching scenes with which the freezing rain can bring. The weight of ice can sometimes be heavy enough to bring down trees and power lines, and the glaze of ice on the ground effectively turns roads and pathways into an ice rink. The freezing rain can also prove extremely hazardous for aircrafts. Freezing rain is more common in other parts of the world, for example in the USA, where weather systems produce a lot of freezing rain. These are called ice storms, and if enough glaze collects on trees or power lines, the weight of the ice can cause them to break and can result in disruption on a large scale. Now, how does it form? Yet, very often, precipitation first falls from a cloud as snow, when it is cold enough high up where the cloud is. If it falls through warmer air before reaching the ground, it can melt and turn into rain droplets. On rare occasions, if it then falls through colder again just before hitting the ground, the droplets can become supercooled, and this means they're still falling in liquid form, even though their temperature has fallen below zero. When this supercooled droplet hits the ground, which is below zero too, it spreads out a little on landing, and then instantly freezes, encasing the surface in a layer of clear ice. This is why it is called freezing rain. Now, how does the droplet become supercooled, you might say? We all know that water freezes at 0 degrees, right? But in the same way that raindrops need a nucleus, microscopic particles of dust or dirt, to form around, water droplets can only freeze around an ice nucleus. However, it is possible that water droplets can exist several degrees below zero and remain in liquid form without a nucleus. This is when they are supercooled. Supercooled water droplets occur in clouds a lot of the time, especially in winter, and they form a very important role in the way that rain forms. Freezing rain tends to start its life as snow, ice, sleet, or hail, but passes through a layer of air that's above 0 degrees on the way down to the ground, melting into a liquid water droplet. If these droplets fall through a zone of sub-zero air just before the ground, they become supercooled. When these supercooled ice droplets strike surfaces that are too close or below freezing, they freeze on impact, forming a glaze of ice. Our third part is a different type of rain. Drizzle. Drizzle is a type of liquid precipitation consisting of very small droplets of water falling from low-level stratus clouds. In the UK, we're very familiar with drizzle. Our prevailing wind from the Atlantic pick up lots of moisture, and therefore clouds, as they travel over sea. To be classed as drizzle, droplets must be less than 0.5 millimeters in diameter. These are larger than the droplets in the clouds, but smaller than raindrops. For the drizzle to form, the cloud must be fairly low to the ground, usually below 1,500 feet from the surface, and so it is more likely to occur in hilly areas. And our final one is about what are the different types of rain. Now, rain is classified according to how it's generated, with 3 main types of rainfall I'm going to tell you. The first one is frontal rain. This is when cold air meets warm air in a weather front. Warm air rises, so when it bumps into cold air, it rises above it. However, like when you're climbing a hill, the higher you go up the atmosphere, the colder it is. So the warm air that is rising up in the atmosphere now begins to cool down. As a result, the water vapor, or a gas, condenses into water, a liquid, forms a cloud, and eventually falls as raindrops. This type of rain can happen anywhere in the UK, and usually brings grey overcast skies and persistent rain through a large portion of the day. Our second one is called orographic rain. When the wind pushes air towards a hill, it is forced upwards, as it cannot go inside the hill. When it reaches the top of the hill, it cools down, as the air higher up in the atmosphere is colder. And if it has enough moisture, the water vapor will condense into water, form a cloud, and eventually fall as raindrops. This is why we tend to see more rain on the hills than anywhere else. And our final one is called convective rain. This is when the sun shines on the ground and heats a shallow layer of air close to it. This air is now warmer than the surrounding air, so it rises up in the atmosphere. The higher you go up in the atmosphere, the colder it is, so the warm air that has risen up in the atmosphere now begins to cool down. As a result, the water vapor condenses into water, forms a cloud, and eventually falls as raindrops. This type of rain is also known as showers, and usually produces small areas of rain, which is why on some days you may get a downpour, whilst a neighbouring village may have stayed dry. This is the type of situation where you will have rain on and off through the day, with sunshine in between, and it seems like the weather cannot make its mind up. The reason that showers are much smaller in size and much more unpredictable is because the ground surface varies greatly across the UK. This means the air close to the ground is heated at different rates, which is why the showers can pop up anywhere and can be blown around in different directions by the wind. If, for example, there is tarmac on the ground, this will heat the air more quickly than a lighter surface, such as grass, or one made of water, such as a lake. That's it for your lesson today. See you soon. Bye. Guys, soon will be our last video. Cannot wait for it. No. Why have I made a mistake?